Okay, so the plan for today is to go over one question, maybe two questions that didn't get explicitly answered in the lesson, which was by design. The videos were getting long, and two, I want there to be something that's not just like a cliffhanger, like, hey, you have to tune back in, but like something that kind of forces you to see if you can figure it out on your own. Where even if you just like don't pause and keep watching, there are still things that are like, well, for you to figure this out, you're gonna have to like really think about what's going on here. So the question that we didn't answer was this one right here. What happens when you graph these points? And by these points, I mean these are the points in the table that we made at the beginning of this activity. So this activity is based on the dots you see to your, where am I going? To your left, right? To your right. Did I get it right? Yeah, okay. To your right. And if you've done this activity, great. You've already done some annotating. You've already analyzed some of these points. Hopefully you've already created a formula. And so now what we want to do is we want to graph that formula. If you have the benefit of a printer, you can print out this assignment and graph the points directly onto this graph, which would be great. If you do not have a printer, then you kind of have to do it on lined paper. And if you don't have grid paper, then doing this is really hard to do precisely, which is kind of the whole point of graphing to begin with. So what I want to remind you of is that you don't have to graph this by hand if you don't want to. You have technology, and you can go over to Desmos, into the grapher on Desmos, and copy the tables into Desmos and graph it there, which is what we're going to do right now. So I already have Desmos open, and we are going to start by making a table, T-A-B-L-E, and it immediately creates a table for us. So the x values we're going to use are going to be the step numbers, 0, 1, 2, 3, 4, 5. And for this activity, it jumped to 10. So those are the step numbers. For the green dots, we'll use pattern number 1. So pattern number 1, I'm looking here, pattern number 1 had 1 dot, and then 3 dots, and then 5 dots, and then 7, 9, 11, and then we figured out it jumped to 21. So those are the dots for the green. And then I'm going to do the same thing, but for pattern number 2. So T-A-B-L-E, and this will be blue. So again, the x values, the x values are going to be the step numbers here. So x value is 0, 1, 2, 3, 4, 5. But the next one we're going to do is not 6 because it jumps to 10. And those are x values. Then we go to the y values, which are 0, 1, 4, 9, 16, 25, 100. Okay, now that I have those tables in place, I'm going to full screen the Desmos activity so that we can compare the images. So first, let's just look at the green dots. So I got rid of the blue dots and we're just looking at the green dots. And what do you notice? When you look at the green dots, what kind of shape do the green dots seem to make? Remember, we graphed 1, 2, 3, 4, 5, and then we jumped to 10. So that's why there's that big gap in the middle. What do we see? What does it look like? Let's see if anyone from chat will answer. Give everyone a minute to think. Oh, it's really dark. Every time I drink my tea, does the colors short out? Yeah, the color kind of freaks out every time I drink tea. Okay, so it doesn't look like anyone from chat's gonna jump in on this one. But hopefully you guys see that like it looks linear, right? The dots look like they're going along in a straight line. Using my mouse cursor, like, do you guys see that right here? Like, straight line, right? Okay, contrast that with the second pattern. What about those ones? Do those ones look linear? No, they do not. They look a little bit more curved. Also, it's worth noting you can't see the last dot because we're not zoomed out enough. The y-axis only goes to 30 here. But remember, the last y value is at 100. So if we wanted to see that, I would need to change the scale of the Desmos graph, which I can do by clicking on the graph settings button here. So if I click on graph settings, I can, on the y-axis, I can make the top y value here, I can make it say 120. And if I do that, oops, that's even more, then I can see that 10th dot, which is way, 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 way higher than everything else. So this does not look like a line. These points are not connected in a line. And the question is, well, what kind of shape are they connected in? And since we have done some extra work before this lesson last week, looking at a couple different shapes, that's not hopefully like a mystery to you guys, right? We've already done this work. We've already named the shape that we're going to be studying. So maybe a better question is, do these points look like a parabola to you? Knowing that a lot of things are missing, do these points look like points along that U shape that you have been looking at before when you're thinking about the basketball, when you're thinking about the football video, when you were doing the parabola gates activity, right? Do these shapes, can you mentally connect the dots in your mind to create that same kind of parabola shape? Hey, how's it going? I see you there. Thanks for joining. Thanks for tuning in. Were you just trying to get my attention, or were you just saying hi? Either way, good to see you. Glad to hear from you. I'm glad you could stop in. So I'm gonna half screen this again so we can go and like answer this question here, right? What happens? Both good. If it's easy to do, type in any questions you have in the chat and I will do my best to answer them. Sometimes typing in math is hard, but do your best and I'll get creative about it. So the question is, what happens when we graph these points? And we say, well, the linear one looks like a line, and the other one, the quadratic one, looks like a parabola. In what is 2 plus 2? In one of the show me's, the show offs where people are like, oh, here's something I think is mathematically interesting. The number of people who wrote 2 plus 2 is higher than you might expect. Why 2 plus 2? Why not 1 plus 1 or 3 plus 3 or 5 plus 8? Like, I don't know. There's some psychology there. There's some psychology there about why 2 plus 2. The answer is 4, by the way. Unless you're doing something tricky that I don't know about, which is possible. I'm looking over here because this is where I see my chat window. I'm not just like randomly ignoring the main screen. Yeah. All right, so that's the answer to this question, right? Lines look like lines. Lines look like lines, and then the quadratics. This one at least seemed to look like a parabola. Let's see. Okay, so there's this last question here that says exponential versus quadratic. And I think like since we have the power of Desmos, I think it might be worth it to like actually just show you guys some Desmos things, just so you get a chance to like see what they mean when they ask you to compare these things. So like, here we go. So if we want to make a line, y equals 2x plus 1. Here's a line. Ta-da! And then if we want to make a parabola, here's a parabola. And if we want to make something exponential, we can do something like this. And so the question is like, what's different and what's similar about these? Exponentials are like particularly, let's do something a little less extreme, just so we can look at it. Exponentials are particularly interesting in this time of your life because of all the information we've had about the spread of the COVID virus, right? Like these shapes are showing up in the news every single day. And it's not because someone is plugging a formula into Desmos. It is literally because the exponential formulas model how diseases spread, right? You could ask like, which comes first, the math or the truth? And the answer is like, well, they both kind of show up. But in our life, we look at the data and we say, oh, that data looks like something we can model using mathematics. Now, what we hope is that at some point, the trend stops going up and we can do something artificial to cut it off, right? The math says if we do nothing, everyone's going to get sick super, super fast. So when we're doing these social distancing techniques, it's us trying to avoid what the math says is going to happen, right? If the social distancing works, the actual data of the graph will look different than just the basic exponential graph. Like that's the dream, that's the goal. Sorry, that was just an important notice about exponentials. So that's our exponential curve. This is a quadratic curve. And if you want to just look at half of it, we can just restrict it to look at half. This right here says only look at the x values that are greater than 0. So it only starts at 0 here. And the quadratic kind of looks like the exponential, right? Like the exponential curves up, the quadratic curves up. Arguably, one of the big differences is that the full quadratic curves up on the other side as well. Like it's like a U shape where the exponential isn't. And when someone's like, well, what is the quadratic model? You actually already know the answers to those questions, right? This shape has already shown up in some of our videos of the day, looking at a couple different things, but most notably the football, when you throw a football. It's shown up on Desmos, when we throw a basketball. And it's shown up in our lesson when we're looking at how to calculate the area of a rectangle. And I'm going to tell you right now, it's also going to show up again in tomorrow's Desmos activity as well, which is a bit more interactive and fun. So if yesterday's Desmos activity was hard, don't worry. Tomorrow's will be a little bit more, I don't want to say easy or hard, but a little bit more user-friendly. Let's say user-friendly. Yeah. So in some sense, like if you're a math teacher and you're looking at this, you're like, aha, yes, this is algebra 1. You spend however much time learning or relearning about graphing lines. You spend a little bit of time learning about graphing exponential functions. And then we're basically going to spend the rest of the year studying how to make more and more and more complex and interesting quadratics or parabolas. So like this thing right here, we're going to get to know it real well. So that's it. That's it. This in a nutshell, if someone's like, hey, what do you study in algebra? Boom, boom, boom. We study lines, we study exponentials, we study quadratics. Not necessarily in that order. But yeah.